So first off, let's start this off by playing a little logic game here. Now the scenario that this is going to go through is when I start this, it's going to start from the trace point and it's going to choose a random number. And if it chooses, say for example, if it chooses A, it's going to move from the trace point halfway up to A. And then it's going to choose another random number. It's going to move, if, for example, if it chooses B, it's going to move from where that trace point now is halfway to B. And it's just going to keep on repeating that process. So if I start it off in slow, you can kind of see it's going through, hopping halfway to the number that it finds each time. If I let it go at this speed, we're going to be here all night. So I'm going to speed it up here. And we're taking a completely random, chaotic series of events, putting a few rules behind it, and we're ending up with something that you can kind of start to see a pattern emerge. And if you were on the Slack chat earlier today, you might recognize the pattern that's going to show up there. So, so it takes a little while, but I think you guys can see the pattern that's emerging, and it gets even more interesting if you project it out to 3 dimensions. And so you get an interesting shape emerging. Now the reason I kind of talk about that is I think that's a lot of kind of what software architecture is. Software development can be kind of a chaotic series of events, new requirements flying at you, business changing their mind and stuff. You know, I think we've all been there. It tends to be a little bit chaotic. And architecture tries to put a set of rules around that chaos and tame that chaos. And so I think if you kind of think of that shape, how random events are flying in there, and compare that to code, if you tame the chaos, you can end up with something pretty cool. So what I'll be talking about here, so this is a quote from Alan Kay. If you don't know Alan Kay, he's known as the father of object-oriented programming. And in this quote, he talks about a lesser idea and a bigger idea. Now, I'm not actually going to be talking about the object-oriented part, but just that concept of a lesser idea and a bigger idea. Here he was talking about he presented this object-oriented concept, and people got stuck on classes and libraries and syntax. But what he was really trying to get across is this big idea of messaging. And the reason I point that out is what I'm going to be talking about today is Idesign. And there's a big idea part of Idesign, and there's a lesser idea part of Idesign. I'm going to be talking about the lesser idea. I'm not really qualified yet to talk about the bigger idea. I'm going to be talking about what happens at the end of Idesign, and you have that architecture and the component pieces we use to build our solutions. The bigger idea, you know, I know that there's a handful of folks here. I'm looking at Jim right now. He's been helping us get up to speed on this in-house at Kiewit. He's been a great resource for the bigger idea part of it. If you're at Kiewit, we're working on setting up training with Yuval, the guy that's behind this Idesign thing. So keep that in mind. What I'll be talking about today is the lesser idea. It's the easier to grasp idea. So the Idesign architecture breaks it down to several building blocks. We have, and these aren't in any order. It's a little bit chaotic. They're in the order that I thought of while I was hand sketching these out. So normally at the top you have managers. Managers are kind of the traffic cop of the components. They're the first entry into the system, and they direct your call to the appropriate pieces. Engines are what I think of as the next piece. They're the pieces that encapsulates your logic. Accessors are your entry point into any database, APIs, files, anything like that. Those are the big pieces. Common, there normally ends up being just a common set of objects that are used across all classes in this project. Utilities, I find utilities a lot of times end up being wrappers around third parties, but they're little reusable pieces of tools that aren't part of your core architecture, but are still needed nonetheless. Ambient context is an interesting concept. Do I have to start over? Ambient context is an interesting concept. That's supposed to be a drawing of a thumbprint or a fingerprint. It's the piece that identifies the user. It's not necessarily the user. It's the context that ties all of these together. Ambient context will be populated right at the beginning before you enter into the system, and will flow throughout the entire application. And then factory. So one thing that you notice about a lot of Idesign patterns is they'll leverage factory pattern for getting their dependencies. And they typically do that instead of dependency injection. But as we'll talk about, there's still friendly ways to work alongside of or next to the dependency injection frameworks. So I know I kind of went through that kind of quick. Is there any questions on these pieces? All right.
Quick question. What's the background of Idesign? Where did it come from?
Have you ever heard, there was a book called WCF, the WCF Bible. If somebody, you've probably seen that book if you worked on WCF. Yeah. So if you've worked on WCF, you probably landed on this page at one point in your career. It looks dated, but there's a lot of good information in this, and not only in this page, but in the individual that's behind it, in Yuval Lowy. He's also got several videos out there where he's talked about either Idesign or just software in general. So it's a good source of information. So with these components, with these building blocks in mind, set out to redesign our user group website, rebuild our user group website. And to be totally honest, our user group website is probably too simplistic for a framework like this, but I really wanted to get a chance to get in there and get hands-on and work with this. In my architect role at Kiewit, I don't a lot of times get a chance to get into the code, so I wanted to take this as an opportunity to dig into it and feel what it's like the same way that our developers would. So our architecture is pretty simple. There typically be more boxes on here, but this largely covers our use cases that we have from here. Now I'm only showing you one slide out of a typical architecture. Keep in mind this is the lesser idea. The full architecture, there'd be several more slides that would support this. And this isn't the first piece that you do in building out the architecture. This is one of the pieces that you're doing in building that up. But basically, when we build out the site, we'll have two clients broken out into the admin client, the one that primarily Matt and I use to manage the user group site, and then there's just the public site that you all use to get information about the events. There's the admin site leverages a group admin manager. And again, that's just the traffic cop for calls coming into there. Just about every use case going through this goes straight through to the accessor, and which hits our Omaha MTG database that we have set up. There are a couple of use cases that use a formatting engine for formatting RSS feeds or for parsing markdown files, and then validation engine for validating input, so that when Matt makes an error on the form, it catches it. So, so this is what the high-level 1,000-foot view of the architecture looks like. This also includes a few pieces that we're not building out right away that I hope to deliver later this year, and that's the Meetup Accessor. One of the bits of functionality that I'd like to add is a connector so that when Matt or I create an event on our site, it automatically calls the Meetup API and creates it out there. I'm not building that out right now, but I wanted to go ahead and plan for it now, just so that I know I have all the bits in place so that when it does come along, I don't have to shuffle around a bunch of stuff. So, and that's part of going through the architecture process too, is working to identify future changes. So with that, we can hop into the code a little bit, and I can kind of give you a quick tour around it. So I know, unfortunately, Visual Studio doesn't scale up the entire UI. I have it set up to scale the code, but as I'm talking about the solution folder, it'll be a little bit small. One of the things that's common in most of the Idesign inspired solutions is they have a very ordered folder structure. So kind of going from top to bottom, there's a documentation folder. Right now I just have a README document in there that explains a little bit about how this is built. Most of my architecture right now is just written on handwritten notes. Once I get that converted to PowerPoints, that would sit here in this documentation folder too. Next down in the chain, I have an infrastructure folder. I do have for running it locally, I do have a Docker Compose file, and that Docker Compose file sits right there in that infrastructure folder. Web clients, again, there's nothing to expand in here. I don't have it actually loading up in Visual Studio, but web clients are my actual TypeScript React files. And then we get into API clients. Our backend is served up purely through an API, and so this is the main. At this point, we're into the main entry point of our system. This is just a .NET ASP.NET Core website with controllers for our entry points into the system. You'll notice if I pull up one of these, I leverage the factory pattern for getting my dependencies. And if you've looked at a lot of .NET Core examples, most of them use dependency injection. I still do. I leverage dependency injection to get my factory, but then once I have that factory, all my further dependencies will come from there. So I'm going through a common interface to get those. And then if I continue to go down through the stack, managers, again, these are the traffic cops of your system. They're the ones that direct traffic and direct flow throughout the system. One thing that you'll notice is I have, if we go back to my architecture diagram, I have one group admin manager. Now what I'm about to show you is something that when I first saw it, I kind of hated, because we've been told for years this is the wrong way to do it. But there's good reasons for doing it, and I think it kind of helps organize your code now that I've gotten used to it, is under my admin manager, all of these CS files are in one partial class. And so they're broken out that way because, number one, they're all in one partial class because they all serve the same core use case. And then so they're all fed by that same manager. There's even though they're partial classes, so they're the same great big thing, each partial class has its own interface. So you can still go in there and say this particular piece of code only deals with this interface and is implementing this interface. So as I go through these, you'll see this admin manager, it implements the iAdmin meeting manager part of it. This particular file implements the iAdmin messaging manager. And so even though we have this partial class, you can kind of see how we can kind of get the benefit of grouping things that are alike in that partial class, but yet separating them down into the different facets that they provide. This is also why the factory pattern is kind of important with a lot of the Idesign systems. If I didn't have the factory pattern, if I just used constructor injection, every time I loaded up this class, instead of getting an instance of the factory, I would get every accessor, every engine that anything else in this uses. So by saying we're just going to give you a factory, and then when you're actually running, get the instance of your accessor at that time, you avoid creating new instances of all of those. So. Yes.
So are you ever using like synchron patterns for any of these dependencies, or will the factory give you a common instance there? It seems like you have the get accessor on there. You're going to create a new instance of that every time you use the process.
You would be every time I request one, it would be grabbing a new one. But it's grabbing it off of underneath the factory. I suppose I should show you what's underneath the factory in this case. That might make it a little bit more easier to understand. Now, the factory is probably where my implementation differs most from a lot of instances of Idesign that I've looked at. My factory, it's just a wrapper around the .NET Core service provider, .NET Core service provider. So all that my factory is it says instance for type T, and then I just make a straight up call out to the .NET Core service provider and get a brand new instance. So if it's registered in that service provider as a singleton, I get it as a singleton. If it's registered, whatever its scope that it's registered at, I'll get it as that. So.
So then, yeah, just some basic feedback on other classes. We did use the lambda operators, to get accessors, then you probably could use that instance. For example, on your other code, you have a user accessor dot,
Right.
you ended up using that user accessor property where it wants to be method. It seems like you would be creating an instance of that each time you access that property. Because of the operator there.
Right. Yeah, I see what you're saying. Yeah.
At the end of the day, that should be a pretty quick operation. If you're doing all that
It's pretty cheap. The rest of it, I mean, we've kind of seen the pattern. The rest of it's just, I don't have many engines in here, so I don't have much to show under engines, but really, architecturally, all of these pieces look really similar. So there's not much difference, but at the end of the day, architecturally wise, there's not much difference between how an engine works and how a manager works, other than they do different things. So, and accessors is down to where I'm actually getting my data. So again, like I say, that's the lesser idea around Idesign. I know there's a lot to process in there. Certainly be interested in any feedback. This is this is piece 1 out of 3 that I'm doing in this presentation, so it's not quite over yet. But if there's any questions or comments on the iDesign portion.
I just have a comment.
Sure.
Just for your question earlier, you would never call a manager twice from a controller. The manager is entry point to the system, and that would be the client stitching together. But for use case, the manager is responsible for orchestrating a set of related use cases. So that particular situation wouldn't happen.
Yeah. Cool. All right. So the next piece I don't have a slide for, but I'm going to talk a little bit about Hangfire. So Hangfire, have you ever, in working with your ASP.NET applications, have you ever had to run a background job? And maybe you're not running in the cloud. Maybe you're just running on premise, and you have to get this background job. In the past, it's been kind of hacky to get that to work. And so in ASP.NET Core, one of the features that they added is being able to run these background tasks and do it in a nice way where they shut down nicely. You still have to be concerned about sharing the processor. So if you do something like generate a great big PDF file, you're still not going to want to do that on the same instance as your website. But in the case that we're using here, basically what I'll be running in the Hangfire job is sending out the email messages that we send out once a month to all of you folks. And so that's a fairly low overhead operation. It's just going to be making out some API calls to an email provider, and we just want to be able to run it in the background, and Hangfire gives us some of that capabilities. Using Hangfire is pretty simple. In my admin messenger, and so this isn't actually the final version of it, but just kind of still working through this, but it's enough to be able to demonstrate Hangfire of it. So basically, Hangfire has this, and I have a small wrapper around it in my utilities. So Hangfire has this background job, and using it is really pretty simple. Is you say background job.enqueue, and you pass it your expression, and it will take that and it'll put that onto its queue. It won't run it right away. It'll actually drop it in its database, and then it'll process it from there. So by dropping it into the database, if your system shuts down before it's able to run it, it still has a copy of it there, and we'll pick it up once your system starts back up. And
Is this just part of ASP.NET Core, or is it a NuGet package?
This is a NuGet package. There is functionality in ASP.NET Core to run background jobs, but you don't get the ability to persist them out to a database and some of the niceties. There's even a little GUI UI that we'll look at here in a little bit. That's pretty slick around it. So ASP.NET Core has the ability to run a background job, but you don't get all the niceties around it. So, but when this runs, basically what we do is first off, I start off by saying queue up my initial task. So I'm going to create one queue to go out and in turn get my users and then break them into groups of 100 and queue them up. I haven't broken into groups of 100 because the email provider that we chose, they have a batch operation, and I think their batch operation could take 150. So I figured give us a little bit of overhead and queue it up in batches of 100. And then once it has it broken out into the batches of 100, it's just calling my my engine that sends the emails. Now in the version that I have right here, I believe it's just doing a simple system diagnostics debug write line so that we can see that it ran with a slight delay, so it doesn't just empty the queue out instantly. And when I run the site, give it a second to warm up. I know why it's not warming up. All right. So I mentioned earlier that I have that I do have a Docker file, and in that Docker Compose file, basically all that I have is I have a SQL server. So I don't know, probably about a year ago, I stopped installing SQL Server on my development machines, and whenever I need a SQL Server, I'll just grab this Docker Compose file, drop it in there, and Docker Compose up, and I have a SQL Server. So I no longer have to have a SQL Server just running in the background. So, just like that, with one command, I almost have a database running. What was that? It's SQL Server running in Linux, yeah. And so now that I have the SQL Server running, the site pops up, and we can go to the Hangfire dashboard. Now, I don't have any jobs in here yet. All right. For the purpose of this, I have that sending the email just wired up to a GET request. Now it's just so that I can fire it off easily. In the real one, you won't be able to go out to Omaha MTG/email and send everybody an email. /API/email. All right. So at this point, I've returned the call, and if we hop over to the Hangfire dashboard, we can see that we got a spike of jobs coming in, and we can actually see succeeded 20 jobs succeeded. If we hop over to output, and we watch it, we'll see the message, and it is basically this WH9RU, because I can't spell. So, and it's just going to say that 1,000 times. Now, if I stop mid-execution here, we should still have a bunch queued up. All right, so I didn't get it stopped very early, but there's one job actually, this is a job that's going to be in an error state. So let me actually start the job up again.
So what's to do with the one that was in progress when you stopped Visual Studio? Will it restart that one or not?
It will restart that one. Let me just run this again so that I can get some more that are in progress. All right, so I'm going to hit this, and then try and stop before it finishes all of them. All right. So there we got a whole bunch that are in different statuses. Some that are actually in processing, some that are in queued, and servers shut down. So if I wasn't using a tool like Hangfire, I would have just lost these jobs. They would have been gone. But since I am using it, as soon as I start back up, it's gonna pick up those jobs off the queue, and I won't have lost any work. Now, if we go and query this, should see, once it gets warmed up, we should see these start to fall off. So we have 69 in there right now. And now we're down to 49. So it woke up, and it's now continuing the task that it was doing before. There is some catches with this. You have to program those tasks, or you have to set those tasks to be up as being reentrant, meaning if it starts it and it doesn't finish it, you have to put the logic in there to say, check to make sure that we didn't complete this, or something along those lines. Because if it stops, let's say it was sending the email message and I shut it down, and it didn't get a chance to record that it was sent that it sent the email message, when it starts up again, it's going to try and send that email message again. So you have to build in the logic in there to be able to say, I'm gonna queue this job up, but check to make sure if you ran it or not. So that's Hangfire. It's a pretty nifty little tool, and it certainly would not be my first choice. If we had access to Azure in building this, there are much better solutions out there. And even if you're using Hangfire, there's an option where it's not running on your web server, where your web server is just queuing those jobs up, but a Windows service is actually doing the job processing. And if you're doing on-premise and you have big jobs to run, I'd certainly recommend the Windows service. But as Matt and I are trying to run the site as cheaply as possible so that we can feed money back out into the group, this is a great option for running some of those background jobs. I think they'll be nice for the emails. I think they'll be really nice for some of our Meetup integration that I'd like to build out eventually. So any questions on Hangfire before I move on to the third leg of this journey? All right. So at this point, and this third piece is the one that I'm most excited about. This is the one that I spent the most amount of time on. So go back to the presentation. All right, so we've all heard of the testing pyramid, right? Where you have UI tests are the slowest and they cost the most amount of money. Then you have, this one here calls it service, typically called integration tests. And then at the very bottom you have unit tests. And the idea of the testing pyramid is you want most of your test coverage coming from the thing that's the cheapest, the unit testing at the very bottom. It's the fastest, going to be the cheapest to run, so it's where you want the bulk of your testing logic typically. I've been spending a lot of my time recently over in the JavaScript world, and in the JavaScript world there's been a conversation going on around the testing trophy, and the testing trophy is really similar to the testing pyramid. However, it adds on static checks, and the static check can be something like ESLint or TSLint, or actually just Typescript itself can be doing your static checking. And that's just, run timing, checking for best practices, checking to make sure that your types are right and stuff like that. So, and then as I was looking for slides, I came across the testing Dorito. The testing Dorito, tests I plan to write, is right there, up there at the top. Then the next one down is tests that test I start writing, and then then one more down is test I delete because I decided they are stupid and take more time than they are worth. And then at the very, very bottom, this tiny bit right down there, that's tests. So so hopefully you're not using the testing Dorito methodology. But I think that this one's kind of an interesting one. I think, in my opinion, all of those tests are important. And if you're going to have a well-rounded solution, all of those tests are important. And if we can make some of these other tests, either service or UI, cheaper, then it'd be highly beneficial for us. And one of the things that I did with this is I didn't do a whole lot of unit testing, mainly because of time constraints. I do have some unit tests in the solution, but I spent a lot of my time in either these service tests or integration tests. And the way I went about that is leveraging Typescript. And so I have let me make sure I have the site still running, okay? So one of the other things that I've noticed a lot as I've been writing front-end client-side code is you can be using TypeScript and you can have that type safety, and it's awesome working with it. However, when you make the jump over to your server backend, you don't necessarily get that type safety of, I thought this was that I was calling this a method that will return this thing, but instead it returns this other thing. So for example, on my post requests, I expect the API to return me an object with a title, a body, a publish start time, and is draft, and tags. However, if I or the service, the API service that I'm calling, makes a spelling change, no amount of TypeScript is going to catch that because it's on that leap from client side to server side. And so what I set out to do is basically build a series of TypeScript tests that I can use to test my API endpoint. Now, in past projects, I've used tools like Postman to go out and build these tests. Postman does a good job of testing it from the outside in. The one big downside is I'm not going to use those assets that Postman generated to actually run my client-side code. So I wanted to be able to take the actual code that I will be running when this is running in production and leverage that in the test. So once we get the final site up and running, my client-side code will be using this post accessor, and we'll be calling methods on here. Now, one of the nice things about TypeScript is I have a lot of functionality that you might be used to as a C# developer. So I have my post accessor, and it's just extending this base accessor, and my base accessor is actually where I'm making all of my API calls. And so you can kind of see how similar to how I would in .NET, I can have this common library that follows common set of patterns, and I'm just extending that for each instance of my tests, and so I'm not having to go back and rewrite it. I'm using classes to do this. Some JavaScript purists would maybe frown on the use of classes instead of pure functions. You certainly could do this with functions, but I think classes are a nice little tool for something like that. Certainly easier to wrap around as someone that's been a .NET developer most of my professional career. And then, so I've actually got my types defined. Defines what a post is, what a request to get a set of posts, and then what a request to create a brand new post is. The other option is delete, and that's just a number, so I don't actually have an interface for that. And then I created a data manager, and this data manager is going to take care of cleaning up the data and making sure that it's basically going to go out there, create my test data for me, and then clean up after itself. And it, again, it's just a class that extends from a base test data manager, and that base test data manager is where all the good stuff is. And so I actually have a method out there to create a resource, and it takes generics. So if I look up here, I have my base test data manager, and it takes a T model, T get request, and a T update request, and a T key. So it should feel familiar to .NET developers as well. And then my actual tests are, again, pretty simple. All that I do, here we go. So I set up those initial parameters that it takes. So when testing a post accessor, this first one is just a method where I pass in a post and then the request that I use to create and update a post, and I simply make sure that they're equal, and then that base class is going to take these and actually run. Here's the post that I created. Here's the post that you asked for. Are they the same? And it's going to call that for every time I include it. Just building out a base GET request and building out a create resource. And for creating a new resource, I use a Faker library. .NET has something similar, bogus, auto bogus. If you've ever worked with that, Faker's doing the same thing, where it's just going to give me, it's just a library that'll give me a random set of words, or a random true/false value, or a random date in the future. And then I just get into my actual jest tests here. And all I'm saying is a post accessor should create posts. And all that I'm doing is calling the function in my base class to be able to say, go ahead and test creating a resource with these parameters. And then a post accessor GET request, including deletes, should return all the posts. And I just go through a series of tests, and because my endpoints are all the same, I can really quickly, easily spin up a new test against a resource with minimal amount of work here. So, and if we run it, so I'll try and so the big screen is the actual test. The screen on the left there, that's actually the .NET output of the .NET process that's running the website. So you can see it's going crazy as it's testing all of these endpoints through actual ASP.NET Core Web API endpoints. And all the tests pass. I actually, in going through this and going through creating these, I actually found one particular issue that I would not have found if I hadn't gone through this outside looking in. It would have made it out there, and it was related to time zones and date time offsets that ASP.NET Core was applying only in the ASP.NET Core pipeline. And so I could look at my manager, the output of my manager, and it was getting the right output, but it was ASP.NET Core that was shifting the time on me. And if it wouldn't have been for these tests actually showing that, yeah, you said created at 4, but it created at 3, I never would have found that issue until we had a user group event that was an hour late because we put the wrong time in. And so, or until Matt came to me and said, when I enter times in there, I have to predate them 2 hours in order to get them to show up at the right time. Because I never would have caught it otherwise. So yeah, that's that's kind of how I'm leveraging TypeScript to be testing outside looking in, and in a way that I think is intuitive enough that you could even have a back-end .NET developer write these classes without really knowing much about TypeScript, and it could be an interesting way for them to start learning TypeScript and get a little bit of exposure to that client-side stuff, and so that's the third leg. Is there any questions on TypeScript or how I'm doing integration testing?
Yeah, can you talk a little bit about the decision to test your API alongside the front end rather than with like a .NET unit test framework right alongside your web API?
Sure. So I do have some .NET unit tests in there also. I don't have a lot. This was a side project, evening and weekends, and it's a little bit hard sometimes to go home and start writing unit tests when you want the site to show up. So I do have some unit tests scattered throughout the system at areas where I know they're likely to have issues. The primary reason that I focused on doing these integration tests is because if I could only do one test, I'd want it to be a test that tested the entire stack, that went through testing every point along the way, and also by tying into the client-side library, my client-side will benefit from those too. So I'll know that when I fire that up from the React page, that accessor, that endpoint, that service will work. And I get that by testing it alongside there. So I'm certainly not saying this is the only type of test that you should do. I think any good testing strategy largely follows that pyramid where most of them are unit tests and then integration and then manual testing or UI testing. But yeah, that's why I chose it. So.
What's the debugging experience like with TypeScript?
So a couple of things I can say around that is, first off, because it is a test that's hitting multiple layers, when a test fails, I don't know where it failed. Because I don't know if it's in my database code, if it's in my manager, but that's I have to, when I see it failing, I have a little bit of research to do where that's actually where unit test is nice because it points you right to what failed. I think you were asking more about just the general TypeScript debugging experience. And one thing that Visual Studio Code does a really good job at is debugging JavaScript code. I have this set up. I haven't actually tested it on this computer, so we will actually give this a try. So I'm going to just test my current file, and I should have put a breakpoint in there before I started that. Unfortunately, it's not finding my instance of Node. But if this was, it's unfortunate that it's not working right now, but if it was, debugging it would be as simple as dropping a breakpoint in there and then hitting F5 and letting it go. But yeah, cannot find runtime of Node on path. Is Node installed? Yes, it is. But actually, I know what happened. Let's try this again. All right. There we go. I just installed Node on this computer earlier today after I had opened up Visual Studio Code. So closing Visual Studio Code and reopening it included in. So we can see I have a debug experience really similar where I can step through and run my tests that way. Feels really similar to Visual Studio. So So we can see it's on the breakpoint right there. I can see the it function. There's also several features of Jest that I like that are probably worth pointing out here real quick. So if I run Jest in watch mode, it's basically going to watch for a file to change, and then it'll rerun the tests. I don't have Git installed in the path. So the reason the reason it uses Git is Jest has kind of a slick little feature built into it, where when you run it in watch mode, it will only run against tests that you've actually changed a file on. So it's just kind of sitting there watching in the background. As soon as I change a file, it will test that file without running my entire test suite. And so it's kind of intelligent in that way. And cool. Any other questions? Cool. I think that's all that I got. Cool. I should make sure that's all that I got. Oh, while Matt's walking up here. So this was a presentation about our website, and this is just kind of a list of where we're at with the new website. The current version, shooting to release that sometime in Q1, hopefully in the first half of Q1. It's mostly function on admin functionality, things that Matt and I do to make our lives a little bit easier in managing it. Actually, stuff that mostly Matt does to make his life a little bit easier in managing it. We're adding a special post type so that we can create an entry without actually having a meeting on there. One of the things that I'm hoping to do with that post type is to be able to call out stuff that you guys have done. So if there's somebody here has done a blog post or something, or came across an article that you think is interesting, I'm hoping to get into a cadence of once a week creating an around Omaha.net post. So be thinking about things that you might want to submit to that. I've heard some folks asking for RSS feeds, and I don't have them on here, but the iCal. So going to add that to the new site. There's some quirks right now around creating your account, resetting your password. I'm sure probably every single one of you have ran into it at some point. Putting an OAuth provider into the site so that if we do something like a code challenge in the future, we can just leverage this for authentication instead of hooking directly into the database. Removing the comments from the current site. I don't think anybody's made a comment on the current site in ages. And I think if you have something to say, go out to our Slack channel and say it to us over there. And then right now, the current site doesn't have any way to view past events. And so I'm going to put in the ability to go back and view past events and past videos. And then further out, ability to cross-post to Meetup, Twitter, attach files to events. And then I kind of want to, I have a little idea for a new winner picker that I might try and build before the end of the year. So that's what we have in store for the website. The iCal? Yeah.
Number one requested feature.
That wasn't on there until Matt told me it was the number one requested, so it's on there. It's on the list now.
Our old site before this one, and when this one came out, we gave it away because we weren't sure anyone was using it. I think within a few days, I got a number of requests.
And in other words, it was a feature that Matt and I didn't use, so we assumed nobody else used it.
Really, much better to create the events. You see how we did the like the recap? That was just a note. I think you're going to add blog support to it as well.
Yeah, it'll be a post type, and so we'll, instead of having to reuse a meeting with a start time and stuff like that, it'll just be a post that Matt and I can share with y'all. And so if you've done something that you'd like to share with the group, that's going to be a mechanism where you can tell us, and then Matt and I will put out actually I think I'm volunteering to put out a regular post somewhere, something like that. So And then the winner picker. I like our Donkey Kong one, but I'm getting tired of it. So I have a really good idea. I have a really good, and I haven't shared this one with Matt, and I want it to be a surprise to everyone. So look forward to that before the end of the year. So.